Hi there. What I hope this to be is to be a brief discussion on Chapter 4, Section 8's presentation of friction. So first off, well, why do we have friction? The reason that we have friction is because even on the most microscopic levels, if you zoom in on what appears to be the smoothest of surfaces, there's going to be these little imperfections that impede any motion against it. And this happens even on the atomic level. You'll have interactions of intermolecular bonds that'll act as friction. So no matter where you move, we live in a frictional world, so we need to start accounting for it. Well, what's the cause of friction? We know that friction is related to the contact of the ground and the object. Well, the harder the floor or the ground pushes up on the object, the greater the frictional force will be. Well, what's a measure of how hard the ground pushes back? That's Fn. Therefore, the frictional force is proportional to Fn. Mathematically, we get this force friction is equal to this Greek symbol mu times Fn. Well, Fn is related to the force gravity, this mg, for any object that's just sitting that has no other motion in the vertical direction. It's actually going to be equal in magnitude to the force gravitational or the weight. So the heavier the object, the more frictional force you get, and that makes sense. This mu right here is a measure of the surface you're trying to push against. So let's say you're trying to push against gravel. Well, gravel, this constant would be much larger for gravel because gravel produces much more friction than, say, glass. If you're pushing against glass, the constant or coefficient of friction out front, mu, would be smaller than gravel. This last statement just says the greater Fn, so the larger the object, the more massive, it would have more weight, and therefore the frictional force will be greater. There's two types of friction. The first is static. Static friction is the force of friction present when an object is not moving because the applied force is not large enough. Kinetic friction, on the other hand, is the force of friction present when an object is in motion. You've probably experienced the difference between these two whenever you've tried to push a heavy box across the floor and you've thought to yourself, if I could just get this box moving, it would be much easier to push. And that thought really comes down to the first form of friction, static friction. So let's talk about static friction first and why we see this kind of less than equal to sign. Well, static friction, like I said, is the amount of frictional force that a stationary object pushes back and opposes an applied force. This coefficient of static friction is denoted mu s, and it depends on the surface that you're pushing against. So let's work an example problem. Let's say we have a fridge that's 90 kilograms and we're trying to push it to the right. Well, the normal force of the fridge is going to be equal and opposite to the gravitational force of the fridge. Drawing in the normal force, remember the normal force is the force between the fridge and the floor or the ground. So it points upward. And the gravitational force is what is pulling the fridge downward. If I want to actually calculate the force friction static, what I'm going to do is note that I need to first find Fn. Well, Fn is going to equal negative mg. I have the mass, so I just need to plug that in there. And then I just need to recall that g is equal to negative 9.81 meters per second squared. Once I have my normal force, I multiply by this 0.4, and I'll find that my force friction static is going to be 353 newtons. Well, there's a reason that you see this less than equal to sign, and that's because this force friction static kind of acts like a barrier. I need to push with at least that much in order to get the object moving. If I push with less than, let's find out what happens. So let's say I push with 100 newtons. That's my force applied. Well, because it's not enough, it's not greater than 353, the object isn't going to move. And Newton's second law says that if the object isn't moving, that acceleration must be zero. So there needs to be a force equal and opposite, and that force is going to be the frictional force. The static frictional force of the fridge. I push with 100 newtons, it's not great enough, so the fridge pushes back with 100 newtons to cancel my force applied. Let's say I push with 200 newtons. Again, because it's less than 353, the fridge is now going to push back with 200 newtons to counteract my force applied. It's not until I push with over 353 newtons that I finally see the fridge move. So let's say I'm pushing with 354 newtons. Finally, in that case, I will see the fridge begin to move. And we've moved past the static case, finally into the kinetic friction case. So kinetic friction is the amount of frictional force that acts on a moving object. Even though the object is no longer stationary, I'm still going to feel the effects of friction. This time we have the coefficient of kinetic friction, mu k. The only difference between mu k and mu s is almost always mu k is going to be less than mu s. Before it was, I believe, 0.4, now it is 0.2, so it's less than, which means the kinetic frictional force should be less than the stationary frictional force. In order to calculate, I just do what I did before. My normal force is going to be the same as it was before, but now I'm going to be multiplying by 0.2. So my force friction kinetic is going to be 177 newtons, which means that no matter what force that I push with, as long as the fridge is moving, so let's say I'm pushing with 500 newtons, which is over my static friction barrier, the force friction kinetic is going to oppose my motion with 177 newtons. If I want to find the net force acting on the fridge, I simply do Fa minus the force friction kinetic, which would mean I'd get 500 minus 177, which would mean I'm going to have a net force of 323 newtons to the right, and that's what I would see if I actually ran this. So that's the introduction to friction, static, and kinetic. The things I want you to be able to do are to state the difference between static and kinetic friction, be able to calculate the minimum amount of force necessary to get a couch moving if the couch has a mass of 50 kilograms and the coefficient of static friction mu s is 0.2, and then calculate the net force acting on the couch once it is moving if the applied force is 400 newtons and the coefficient of kinetic friction is 0.1. So in that last case, if I push with 400 newtons, I want to find the force frictional kinetic and subtract that from my 400 newtons in order to get my net force acting on the couch. I thank you for your time.